There's a video on some new stuff, basically from kind of chapter 8. So we have trig form. So trig form is r times cosine of theta plus I sine of theta. And so here we have a complex number, so complex numbers in the form of a plus bi, or you could even put it in the form of same thing as x plus yi. It doesn't really matter, but we're used to a plus bi as complex number, but you can do x and y. And remember, cosine of theta is equal to x over r, but if we're on the unit circle, our r is equal to 1. So cosine of theta is basically just x, and similarly, sine is equal to y. Sine of theta is equal to y. So that's where you can kind of see this is x plus yi, and we get cosine of theta plus I sine. So it's kind of like the x plus I y. And then we just have our r. Well, how we find our r is Pythagorean theorem, because we're on a unit circle. So a plus bi, so you can do r is equal to the square root of a squared plus b squared, write the distance from 0. Or you can do r is equal to x squared plus y squared. It's the same thing here. So, and then to get our theta, so all we need is an r and our theta. Well, our theta we can find by taking our inverse of tangent. So tangent is y over x, right? Or sine over cosine. So it can be the inverse would give us our angle of y over x, or you can do a and b over a. The inverse of that is going to give us our angle. Okay, so first we label our a and b. Well, a plus bi. B is just what's next to the I, or how many i's you have. So for the first one, a is just -1. So a is equal to -1. Or sorry, not a, but b is equal to -1. And a is just the real number. So a is equal to +1. Or you can do x is equal to, put it under here, x is equal to 1 and y is equal to -1. So anyways, we square those. So I'm going to take 1 and square it, and then I'm going to take -1 and square it. So we get 1 and 1, and then we square root that, and that's our r. So r is equal to square root of 2. So r is equal to square root of 2, and then we need our theta. So our theta is b over a, and the inverse, tan inverse of that, or y over x, same thing. So I take 1 over, or -1 over 1, and then I take the tan inverse of that, and that will give me my theta. So where is tangent -1? -1. So tangent's negative in the first quadrant and the fourth quadrant. So to determine what quadrant we're in, we'll go ahead and graph this. So if we graph this, we go over on our x-axis, 1, and down on our imaginary axis. So our real axis is left and right. That's our a or x, and then b is our y. So our point's right here in the fourth quadrant. So really this is going to be 315 because it's based on a 45. So 315, that's going to be our theta. So now we have our r, root 2, and our theta. So now we can go ahead and write r times cosine of our theta, and then plus I sine of our theta. So I use the same theta, I don't change numbers here. So it's the same 315, 315. So that's our answer for that one. Our second one is -2 root 2 plus, what's that be, 2i, plus 2i. So there is our b or our y. So that's b or y, whichever one you prefer, and this is our a or our x. Okay, so then we can go ahead and square those. So that'd be 4 times 2 is that -2 root 2 squared. And then I'm going to add 2 squared, which is 4, and then I'm going to square root that. So the square root of 812. Oh, sorry, that's a root 3. 2 root 3. So that is 2 root 3. So that's 4 times 3, which is 12, and 12 plus 4. So that's actually root 3. So we get 16. Square root of 16 is 4. So our r is equal to 4, And now our theta, we take our b, divide it by our a, or y divided by x, root 3. These will cancel, so I get negative 1 over root 3, which is rationalized to root 3 over 3. And so we get negative root 3 over 3, and I want to take tan inverse of that. So again, where's tangent? Negative root 3 over 3. And it's in either the third, or the second, or the fourth quadrant, because it's negative there. And then, so that'd be pi 6, or is our reference angle. And because it's negative, so it's either 150 or 315. And so again, I can go ahead and graph that irrational one. So I go over negative 2 root 3 on my rails, and then up 2. So I'm actually, somewhere over here in the second quadrant. So it's going to be the 150. So it's going to be 150 is my theta, or I can do 5 pi 6. That's fine. So I do my r, which is 4, cosine of my theta, which is 150, or 5 pi 6th, and then plus I sine of that same theta, 150 or 5 pi 6th. And so there it is. So a little bit easier one we'll do when we have polar forms. So here's polar form going to rectangular form. So rectangular form is kind of just like a complex number, or just our regular x's and y's kind of thing. So polar form is given in the form r, comma, our theta. So here's our r, and here's our theta. Okay, so when we do this, we go ahead and take, we have our r, so we can go ahead and put in negative 3, parenthesis, cosine of theta, which we know is negative 135, plus I sine of that negative 135. And so there we go. Now we just solve this. So here it's a little bit easier because we already have our r and theta, and now we just solve this. So cosine of 135, well, that's based on going negative, so it's going this way when we open up. So we're in the third quadrant, so cosine and sine in the third quadrant are negative, and it's based off a 45-degree angle, so negative root 2 over 2 and negative root 2 over 2. And this is being times by I, so I can put the I behind it. That's fine. And then so I can go ahead and distribute that negative 3, so I get positive 3 root 2 over 2 plus positive 3 root 2 over 2 I. And so there it's in complex number form. So that's our rectangular form. So basically you just plug in your r and your theta, and then you just simplify. Okay, so here I'll do one more, and then in the next video I'll do the triangles again. So here we're doing parametric equations. Basically some of them we just want to put in the forms that we know. Right, so if I just take this one and put it in form of just solve for t. So if I solve one of these for t, particularly this one, because this one, well, yeah, we can just solve for t here. So we go ahead and solve this one for t. So we go ahead and subtract 4 on both sides, subtract 4. So we have y minus 4 equals negative 2t divided by negative 2 divided by negative 2. And I get y minus 4 over negative 2. I could distribute that negative if I want to, but that's okay. So there's t. Now, normally if this equation over here, I could just plug in that t right there. So that's one way to do it. Another way is just to take this second equation right here and just solve for t as well, and then just set them equal to each other. Either way is fine. So basically it's kind of like a systems of equations a little bit with substitution rule. So I'm going to plug this t in. So x equals 3, well, maybe I won't, just because I think in the notes I didn't. I probably took this other one and solved for t as well, so I'm going to subtract 6. So maybe I'll just do that. Subtract 6, so x minus 6 equals 3t. And then we go ahead and divide by 3. So we get x minus 6 all over 3 equals t, and t equals t, right? So we can set these equal to each other. No, sorry. Equals y minus 4 all over negative 2. So now basically it came into kind of rectangular form. So now basically we just solve this for y, and then it's kind of in rectangular form here. So those are going to cancel. You get y minus 4 over here. Distribute the negative 2. negative 2x plus 12 all over 3, and then we can leave it like that, or we can simplify 2/3 x, because then it's kind of look like an equation that we could graph, right? Plus 4 equals y minus 4, add 4, add 4, and so we have a rectangular, what we call rectangular form, basically an xy form, right? This is an equation for a line, right? Y equals that, so I could actually graph that now. Now, to know what my parameters are, I look back at what they give me. So t is between -3 and 2, so I just plug these -3 and 2, -3 and 2 in for my t's, right? So I plug them in and see what my parameters on my x's are. So I plug -3 in and 2 in and see what my parameters are. So I need to go ahead and find out what my parameters are for my domain, right? So here's my equation as a line, y equals, what was it, 2/3 x plus 8, something like that. Negative 2/3. Okay, so it's a line, so I need to know what my x's are. Well, here are my t's, -3, -2, so if I plug in mine to my x's, because it's just a line, I can just plug in my x's. So basically I could graph this and see, kind of what's it doing, something like this. So I need to find out what my domain is for my range of t's. So I plug those in my x's, so I plug in -3. I get -9, -9 plus 6 is -3. So I'm going from -3, and then I plug in 2 in there and see how far I go. So 2 would get me 6. 2 would get me 6, so we get 12. And so we're going to 12. So those are going to be my parameters of my domain. So all x's in. So my x's will be from -3 to 12. So there's my diameter. There's my parametric equation with its domain. Now sometimes it might change a little bit, different depending on the equation. Usually you can solve for t and then either plug t into the other equation or set them both, solve for t and set them equal to each other. Here's another example. Okay, so here we have x and y, and so we can't solve for t because t is inside the trig function. So what we want to do is we want to use the fact that I want to kind of combine these. I could add them, right? But I want to make sure that my x's and y's, when I put them together, that I can use some form of identity to maybe combine cosine and sine so that they kind of disappear. So I know the only way to get rid of sine and cosine is by using this, and cosine, that equals 1. But these aren't squared, right? That would equal 1. But they're not squared, okay? So what I need to do is square these. So if I go and square both sides of each equation, then I would get x squared is equal to 4 sine squared t, and this one would be y squared is equal to 9 cosine squared t. Now, if I add these two, so I'm just going to add these two equations, so I'm going to take x squared plus y squared. Well, if I take x squared and y squared and add them, that means I have to add what they equal, right? So I have to take 4 sine squared t, and then I have to add 9 cosine squared t. So now I'm going to have to go ahead and divide, get rid of, divide by 4, so that means I'm going to divide. Well, I guess I probably should do that over here. Divided by 4, divided by 4, divided by 9, divided by 9. Then that gets rid of that. So x squared over 4 plus y squared over 9, we can go ahead and get, we'd have sine plus cosine squared. So sine squared plus cosine squared equals 1, because it's Pythagorean identity. And now this looks like an ellipse. Right, an ellipse always has plus in the middle, so it's always dividing by a squared or b squared underneath here. So a normal circle would just be this, r squared. But when I have something like that, and this is equal to 1, that's an ellipse. So our equation forms an ellipse, which we could go ahead and graph. How do we spell ellipse? This, where it just equals r squared, that's a circle. And then the other one, a hyperbola, probably spelled that wrong too, but that's okay, it's just a minus in between, so it's an ellipse with a minus in between. And that's theta equal to 1. So the only difference between an ellipse and a hyperbola is just it's a minus in between. Alright, so that's it for this video. On the next one I'll do the triangles again. So I think that's it for the new stuff.